Another interesting use case for locking is the what we call reader-writer locks, and this is a classic problem that you find in databases, in parallel processing systems, in data processing systems. It's very common in computer science, where you basically have the case where of data that can be mutated and that can be read by multiple users at the same time. Let me give you an example. A Wikipedia entry, for example, is so any page on Wikipedia. When you look it up, there are multiple people, there are probably millions of people who can read that document at the same time. On the other hand, the number of people who actually write to that document is probably in the order of 5-10 people. I mean, on really popular articles like the Barack Obama article, you might have like 130 contributors or something like that. But in general, you have many more reads than you have writes. Basically, you have the most of these articles are written once, never updated for a couple of years, and then read through these years maybe hundreds of times. So the idea is basically you want to allow you want to allow basically inserts to be atomic, and to make sure that not no concurrent writes are being done, such that you get garbled data or you get data inconsistencies and so on. But you want to be able to have many people reading, or many threads reading this same data in parallel concurrently. So reads are concurrent, writes are atomic. And they are not just atomic, they are atomic and they are allowed for a single thread at a time. So this is the reader-writer lock data structure. You basically, this is how it will be implemented. You'll have two semaphores, one that is a general lock, a basic lock on the data structure so this is a very basic lock that you need to basically acquire to change anything in the write lock. So it's sort of a lock for the write lock. And you have a semaphore for the write lock, and you have a number of readers, count of readers. Okay, so this is basically your read write lock struct. Okay, when you initialize the lock, you basically initialize the number of readers to 0 in the beginning. No one is reading the data until basically the data is online. You initialize the read write you initialize the general lock to 1 as the semaphore. You initialize the semaphore to have a max number of 1, and you initialize the write lock to 1 also. So this code is pretty simple. I mean, right now we have not done anything. For the writer, we know that when someone is writing, no one else can basically touch the data. So once you have someone writing, then all other writers have to wait, and all other readers have to wait also until the write operation is done. So it's quite simple to lock the struct. You basically call wait on the write lock. Okay, and when you are done, you want to release the write lock, you call post on the write lock. So I mean, it's quite simple. You acquire the write lock, no one else can do anything. Okay, now for the readers, it's a bit more interesting, because you first, in the beginning, to acquire the read lock, you lock the whole data structure. So you acquire the general lock. Okay, because when you acquire the general lock, you're going to also change the readers. Okay, so if you acquire the general lock, no one else can change the number of readers. Here in this code, the third line, in readers, you want to acquire a lock that does not allow anyone to basically change the number of readers until you are done with incrementing the number of readers. So you add a reader. Okay, if there are any readers, if the number of readers is equal to 1, if there is at least one reader. Okay, sorry, if there is only one reader, sorry, if there is only one reader, not if there is at least one reader, if there is only one reader, if you are the first reader, you go in and try to acquire the write lock. Basically, when you acquire the write lock, you're going to stop any writers from writing to the data, to the data element that you're going to change, to the file that you're going to change. So you try to acquire the write lock. Okay, if any writers have the write lock, then you will have to wait for it. If no writers have the write lock, then you acquire the write lock. Okay, so now you have the write lock, and then you post the lock. You release the general lock. Okay, when a second reader comes in, he basically will go through this code again and will basically check if the lock, the general lock, is acquired. No, it's not, because the previous reader has released it. Increases the number of reader to 2. Okay, so instead of it just went from 1 to 2 readers plus, so you go to 2. Now this next reader does not need to try to acquire the write lock, because since there are 2 readers, then we already know that the first reader has acquired the write lock. Okay, and as the first reader has acquired the write lock, then the second reader does not need to acquire the write lock because it's already acquired. So the second reader can just skip this step and go to post again, basically releasing the lock, so that when new readers come in, they can acquire the general lock, again increment the number of readers. So now we have 3 readers. Checks if there are any, if readers is not equal to 1. Okay, sorry, if readers is equal to 1, no, they are not. So you basically they are equal to 3. You basically know that one of the first 2 readers have the lock. I don't need to check it, and it goes to post. Releasing the lock, I mean the first reader who got the lock will basically do the following. It will first acquire the general lock, which basically allows it to change the number of readers, decrements the number of readers, because I'm the first reader, I'm leaving now, I'm decrementing the number of readers, so I'm going from 3 readers to 2 readers now. And now check, am I the last reader? No, there are 2 more readers, so I'm not going to release the write lock, I'm going to leave it. Okay, and I'm going to release the general lock. Now there are 2 readers in my system. One of them wants to exit, calls release read lock. Okay, again acquires the general lock that allows it to change readers, to change the number of readers, decrements readers. Okay, so now there is 1 reader. Are there any readers remaining? Was it the case that I was the last reader? No, there is 1 remaining, so I'm going to skip that releasing the write lock, and I'm going to post the other lock, basically allowing other readers to decrement the number of readers. And now the last reader comes in. There's just 1 reader now left, so it calls lock. It acquires the general lock, decrements the number of readers. Now there are 0 readers. So are the number of readers equal to 0? Yes. So now it can post to the write lock, basically releasing the write lock, and now any writer can acquire the write lock. Okay, so now you have it released. So the idea is that now we have allowed multiple readers to access a shared structure by locking the write lock on the first reader. Subsequent readers will know that the write lock is already locked, so they can proceed. Okay, this code has an issue. Can you think of it? It's actually starvation. I mean, because suppose that you have an influx of readers, you have 1 million readers, that you have 1 million readers constantly coming in, acquiring the read lock. I mean, once the first reader comes in, then there is no writing after that first reader, right? If there's basically an infinite amount of reader streams coming in, then the writer does not have a chance to get any write time. So this is now the issue with the read writer lock. Of course there are solutions to this, but I'm going to skip them.